To join the 3 red chips, 1 green chip has to be left at last, because if the 2 green chips are withdrawn and if 1 red chip is at last, whenever the 2 green chips are drawn, then the game stops. So 1 green chip has to be at last in order to calculate the probability of the 3 reds are drawn. That means the probability of the 1 green chip to be left at last to drawn is the same as the probability of the 3 reds are drawn. And 1 green chip left at last, the probability is the same as if we choose the green chip at first. So if we choose a green chip at first, the probability is 2 out of 5 because there are 2 green chips out of the total 5 chips. So the answer is B. Problem 22. To solve this problem, let's assume BE and CF crosses at O. And then we draw a vertical line from B to EF. It crosses EF at M. And we draw another line from the center of AF to BM. And this is vertical, and it crosses at N. Because also let's assume the center of AF is L, because AL equals LF, so AL equals 2, LF also equals 2. And BN also equals 2. Now, let's look at angle ACF triangle. Because L is the midpoint of AF, therefore N is the midpoint of CF because LN is parallel to AC. So CN equals FN. And BN becomes the common bottom of triangle BON and the triangle BNF. Now, the shaded area BOF equals the area of triangle BON plus triangle BNF. Triangle BON, the area equals 1/2 BN. To get its height, we know that because BOF and COE are identical triangles, therefore, if we draw from the midpoint of AD, it should cross O. So the height of triangle BON should be 1/2. And plus the area of triangle BNF is 1/2 multiply its bottom BN multiply its height is LN, which equals 1. and that equals 1/2 multiply bn is 2 multiply 1/2 plus 1/2 multiply 2, and that equals 3/2. And the total shaded area is double the area of BOF, so the total shaded area should be 3. To solve this problem, we know that AB equals AE equals BE equals the radius of the two circles. Therefore, angle AEB equals 60 degree. And also angle CAE equals 180. Subtract angle EAB, and angle EAB equals angle AEB also equals 60 degree. So that's 180 subtract 60 equals 120. Then we know that angle CEA equals 1/2 angle 180 subtract angle CAE, because AC equals AE equals R here. These are all R's. So that means it's 1/2 180 degree subtract 120 degree, and that equals 30 degree. Similarly, we can get angle BED also equals 30 degree, and angle CED equals the sum of angle CEB plus angle AEB plus angle BED. That's 30 degree plus 60 degree plus 30 degree. That's 120 degree. So the answer is C. Problem 24. To solve this problem, the key is to identify that because the 3-digit number QRS is divisible by 5, so S has to be 0 or 5. Because the digits only go from 1 to 5, that means S is 5. Now because S is 5, then for RST is divisible by 3, we can get that R plus S plus T is divisible by 3, which is R plus 5 plus T should be divisible by 3. And in order to achieve that, R and T can be either 1 and 3 or 4 and 3. Now let's look at PQR. PQR is divisible by 4. That means QR is also divisible by 4. Because QR is divisible by 4, then R should be even. Now R can only be 1 or 3 or 4, so R must be 4. And for QR to be divisible by 4, that means Q must be 2. And from the statement here, we also know that if R equals 4, then t should equal 3. Now the only number left is 1, so p must equal to 1. Problem 25. To solve this problem, we assume the angles of the triangle is A, B, C, and we draw a vertical line from A to BC, which will stop at the center of the semicircle, and let's assume it's O. And then we draw another vertical line from O to AB. It crosses AB at the point where the circle and AB crosses. Let's assume this point is D. Now we know that AO's length is 15 and BC is 16, therefore BO is 8. Because AO is perpendicular to BO, therefore the length of AB equals the square root of AO square plus OB square, and that equals the square root of 8 square plus 15 square, and it equals 17. Now let's assume OD's length is R. We know that OD is perpendicular to AB, so these angles are right angles. Because BDO and ADO are right angles, therefore we know that BD equals square root of BO square subtract OD square, and that equals 8 square subtract R square. And AD similarly equals to square root of AO square subtract OD square, and that equals 15 square subtract R square. Because AD plus BD equals AB. Now we plug these results into this equation. We can get square root of 8 square subtract R square plus square root of 15 square subtract R square equals AB square equals 17 square. And we take squares on both sides to solve this equation. So that's like that. And then we simplify this, we can get it's 8 square subtract R square plus 15 square subtract R square plus 2 multiply 8 square subtract R square multiply square root of 15 square subtract R square equals 17 square square. This should be 17 square because it's AB square. Okay, now let's further simplify this. Because we already have on here 8 square plus 15 square equals 17 square. So here we can cancel this out. Now that becomes 8 square subtract R square multiply 15 square subtract r squared equals r squared. Now let's take the square on both sides again to simplify this equation. Then we can get it's 8 squared subtract r squared multiply 15 squared subtract r squared equals r4. And we further simplify this side, we will get it's 8 squared multiply 15 squared subtract 8 squared plus 15 squared multiply r squared plus r to the power of 4 equals r to the power of 4. Now we can cancel out r to the power of 4 on both sides. Then it becomes r squared equals 8 squared multiply 15 squared divide 8 squared plus 15 squared. And that becomes 8 squared multiply 15 squared divide 17 squared. Therefore, r equals 8 multiply 15 divide 17. That's 120 divide 17. Now let's go back and look at the answers here. So it should be answer B.